Next curve.
Hey everyone, welcome to this Next Curve Rethink podcast episode where we break down the latest tech and industry events and happenings into the insights that matter. I'm Leonard Lee, executive analyst at Next Curve. And yes, we're in a rush here because we don't have that much time, but this is the Silicon Futures episode. We will be talking about the happenings in actually a number of events and things that have occurred in the last couple of weeks, right? So this is a little bit of an ad hoc episode, but I am joined by the highly accelerated and scaled up and scaled out Karl Freund of Cambrian-AI research and the 4D packaged Jim McGregor of TIRIAS research. What do you guys think?
4D?
You good?
I think 4D.
I think you're getting more gray in your hair, Leonard.
4D.
At least you've got. Hair.
Well, yeah, I know, but I think his mind's going with it. So I don't know.
Hey, it's been a crazy year. I'm losing it. Yes, you guys are tuning into like a big challenge I have keeping myself together. But anyways, hey, before we get started, please remember to like, share, react, and comment on this episode. And also subscribe here on YouTube and on Buzzsprout to listen to us on your favorite podcast platform. Opinions and statements by my guests, that means these two guys, are their own. And, I think they like it that way because they like to be independent and don't reflect my opinion at all. Right, guys?
That's because yours isn't right, so
Yeah. Well, that makes it easy. And we do this all to provide an open forum for discussion and debate on all things related to the semiconductor industry, which is the foundation of almost everything that you can imagine, according to Jim. And probably Karl. But hey, a lot of stuff going on. This is complete insanity. Karl, you and I were at CadenceLIVE. Jim, you were at IBM THINK. So there's a lot. It looks like it. So let's start off with you because you're the one who really bugged me about recording something, I think. Or was it the other way around?
I think it was me.
Okay.
I don't know.
All right. So we're going to let you kick things off, okay? Because I think Karl and I are very curious about what you saw at THINK and what your takes were there. And then I think, Karl, you and I should really provide some insights and perspectives and share with Jim what we saw at CadenceLIVE, right?
Well, and also building on CadenceLIVE, you got to remember there were two major events for semiconductors in the previous weeks with the TSMC Symposium and Intel Direct Connect. So a lot of it. So mine was more focused on systems and services. The rest of it was pretty much focused on semiconductors. THINK, as you know, is pretty much IBM's big conference to present itself and all of its works and its wares. And IBM, for the most part, is a software and services company with some systems, obviously, with their still maintain their mainframes with the Power and the Z series, a Linux 1 series. So this year is really building on everything that they keep doing. It's very similar to seeing NVIDIA with AI. It's IBM in the enterprise and providing complete enterprise solutions, from those secure, highly reliable mainframes for transaction or critical processing elements to, providing the different elements. So one of the coolest things that they talked about, two cool things they talked about this year. One was Watson X Orchestrate. Now, this is something they introduced several years ago, but it's morphed over time. And this is kind of really an all-inclusive AI orchestrator for the enterprise. And one of the coolest things about it now is now they've turned it into being able to do custom agents within 5 minutes by selecting other, AI models and stuff that are out there to where you can actually customize an agent. And they've already got some pre-customization ones for elements like HR or purchasing or stuff like that. But the fact that you can take a lot of that structured data and now unstructured data, that's a critical element that they've added to it now as well. And these different pre-designed AI models, whether it's from IBM or a third party or in-house or whatever, and really create custom agents to be able to do just about anything within an enterprise. Very impressive. Also being able, they also have a solution, a hybrid kind of orchestrator, or trying to remember what they call it, but basically to implement and automate a lot of the processes with the enterprise. So it's interesting to see how, like I said, NVIDIA on one side is really kind of that enabler, and IBM is really kind of that, I would say that second half of the puzzle in a lot of cases, where they're, enabling the enterprise to be able to do all these things. And they provide complete, obviously, consulting services to help walk companies through this process. So it's pretty amazing to see how, they keep evolving AI for the enterprise. And one thing that we've said in the past is, they're kind of AI enterprise ready out of the box. And, everyone else keeps struggling with working with developing their own models, using open source models, working with in-house data scientists or external consultants. IBM comes in and has like this huge portfolio and says, pick and choose what you want. And still having mainframes that are very, very competitive in the market.
So how is that different from like what Salesforce is doing with Agentforce and, because that's sort of a platform play. Oftentimes IBM is, from a software perspective, at the platform level, right? They're not necessarily SaaS or application level. That's typically what you see with SAP or Oracle with their applications. And all these guys, these ISVs are also introducing their own agentic frameworks and stuff like that. So, it was weird because when you mentioned all this stuff on chat that we had earlier, I was thinking, are these guys getting into ERP? Are they trying to replace ERP? Because if these are function specific, out of the box stuff, and you're stitching them together with the orchestrator, which is like, for people who who've been working with enterprise software for a long time, know that workflow and business process management tooling is not a new thing, right? Where is IBM taking this stuff? And it begs that question. You know what I'm saying?
And very much so. And IBM's coming from a different realm. IBM, especially with their mainframe solutions, and they've done a great job. The mainframe is still very applicable. It's that highly reliable, highly secure, high-end processing solution. But they've kind of morphed it into a standard rack. In 2014, they went to a standard 19-inch rack. So it looks like any other rack you'd see in a data center or on a hybrid data center. But they're already critical for financial transaction processing, healthcare processing, military and defense applications. So anything that's it has to be highly reliable, highly critical. And now, so instead of kind of bringing it up to the enterprise, they're bringing it down from the enterprise from, I would say, the most demanding type of work applications that you'd have. And they even noted during the conference that, they are seeing both existing and new customers. Yes, there are actually new customers for mainframes, believe it or not. They're seeing, moving from just using these for critical applications and using their processes and everything else to actually running standard applications on the mainframes and even now AI applications. In one demo they said, listen, in some cases we've seen a customer go from 286 processing nodes, x86 processing nodes, down to 16 processing nodes on one of their Linux One systems. That provided huge savings, not to mention, smaller form factor and everything else. Yeah. And then that's going to be different for different applications, obviously, and how you're using those data center resources. But it also provides a lot of cost savings and a lot of consolidation within the data center, which is important today.
You know,
I think they're doing a good job of bringing AI to where the data already resides, right?
That too.
Both on the Telum 2 processor with the AI accelerator for not generative AI, but for simpler.
Actually, generative AI too, but yeah.
But generative AI really is more focused on Spire accelerator card, right?
That's
It's an
true.
IBM designed inference processor that you can rack and stack as many as you need and attach them into your Linux One system and in the future right now on System Z. And that way you can do some very sophisticated AI right on the mainframe. You don't have to migrate it off to an x86 server with NVIDIA accelerators. You can do it all right there, and I think that's a major step forward for IBM and their clients.
And having an accelerator on the Telum 2 processor, as well as on the Spire accelerator, gives them kind of the hybrid AI strategy in a single platform.
Mm-hmm.
Well, you know, I want to point out something that's really ironic here. It's for the longest time, IBM had subscribed to this notion that software was eating the world, and that they needed to make this huge migration to software, becoming a software more of a software business, right? Mm-hmm. Yet we are talking about hardware. And now how that hardware is such a necessity and an essential part of the whole now, I think, system discussion that everyone's having right across the board, even at Cadence, right? It's all about the system. And anyways, I wanted to point that out because, I have a long legacy with IBM because I was...
You worked there
for a long time. Yeah. And Karl worked there too. So
I worked there for 10 years. And
I did.
Power and Z. So
but you worked with IBM for...
I have, and it is impressive to see. And you're right. And their software strategy is, I would still say, the crux of it. It's nice to see what they're doing with mainframes, but the mainframes wouldn't exist without the software. I mean, they're introducing new Granite models constantly, and those are open source models for enterprises to use. Not to mention, like I said, all these other tools and assets that they can use. Lakehouse for actually managing diversified structured and unstructured data. So, I mean, it's very much they continue to build out that portfolio to support the enterprise. That's probably the most impressive part of it.
Okay, cool. So really quick, go ahead.
I was going to put this in. They added one of the few companies that have added support for Cerebrus wafer scale engines within the IBM cloud. So now you can access an IBM cloud, and you can go all the way from embedded AI processors all the way up to a Cerebrus rack for fastest inference processing on the planet.
Yeah. Wow. Yeah. Thanks for reminding us. Yeah. Glad you're covering that stuff, Karl. So really quickly, Jim, you mentioned TSMC and Intel Connect. Neither Karl or I attended either of those. So maybe you can, share quick highlights and takes.
Well, these were both focused, obviously, on semiconductor foundry services, but really highlighting the technology. TSMC introduced their A14 process node upcoming, while Intel was talking about the status of its 14A process node, not to be confused. And despite the similarities in numbers, the processes are completely different. Intel's trying to use, they haven't committed to it yet, a high NA lithography on their 14A. TSMC says absolutely not. We're not going to use that for A14. So different strategies there, but definitely showing that the fact that the semiconductor process technology is still continuing to advance, and the process nodes. TSMC noted that they expect significant improvements in performance efficiency with the A14, similar to what Intel's looking at. And matter of fact, Intel's really big jump, I think, is with 18A, which goes into production this year. But 14A provides them a lot more flexibility. That's where they see some derivatives that they're introducing that will be more applicable, not just to server and high AI and HPC environments, but also to mobile and other environments. But despite the processes, really the shining star of both events was packaging.
Yeah. Yeah.
Just the advances in packaging. The CoWoS-L that TSMC is talking about, which they refer to as silicon on wafer, and as well as Intel's EMIB and Foveros solutions. They're basically doing chiplets on chiplets on chiplets. It's almost going to look like a chiplet city almost when you start looking at these solutions. The amount of integration at the packaging level is just so mind-numbingly intense. It's incredible, and dense. It's incredible. And Intel obviously would seem to have the lead with the backside power, because it's not just a packaging technology to them; it's also a silicon technology, and they're architecting their silicon to be able to do that. So it's going to be interesting. And even though we think of these two as being competitive, the real way to think of them is being very complementary. Because as we get to those silicon on wafers or these city of chiplet solutions, you're going to have to be using probably die from multiple foundries. I mean, Intel's not going to be competitive price-wise in some of the older foundries. They're trying to be competitive on the newer ones, and they may be a little bit more advanced on some of the newer ones, especially with the backside power and stuff. So you're going to see. I don't know of anybody, especially as they start getting these really dense configurations, they're going to be using chiplets from a single foundry. They're going to be having to use it from multiple ones. Matter of fact, one of the interesting announcements is Intel kind of builds out its ecosystem, which TSMC already has in place. They announced the new value chain alliance and a new chiplet alliance. And part of that was also partnering with Amkor. So not only are they offering their own, advanced packaging solutions, but they're going to be working with Amkor to be able to do it too. And Amkor is building a brand new facility in Chandler, Arizona, to be able to offer some of those efforts. Yes.
Wow.
And then that's where the two main Intel fabs are going up right now, 52 and 62. So, big bonus for Arizona, but also I think for the ecosystem to see how all these entities are working closer together. So even though we think of these guys as being competitive, they really are going to be very complementary. And Intel's making strides. Synopsys got up there and said, listen, for the first time, we have a full tool chain that's fully optimized for 18A. I mean, that's a huge statement to say. But they had Siemens was there, Cadence was there, so obviously there was support from the entire ecosystem. But seeing the foundry really start to come together. But once again, I want to hesitate, and when I say this, it's still going to take Intel, another 5 years before that foundry really all meshes together and really becomes a competitive solution. Because once again, they're going to have to work with the other foundries. They're going to have to work with the rest of the ecosystem, and they're still learning how to be a foundry.
Yeah. And it makes you wonder, is that too much to bite off and chew?
Well, I think they're getting so much input from the industry. And obviously there's a lot of stakeholders here. There's the US government, there's the other Western governments, Japan and Europe, that are investing in a lot of the Intel Foundry service as well. So I think they're getting so much input that, it took Global Foundries a decade before they could really learn how to be a foundry. I don't think it's going to take Intel that long, but obviously still putting the fabs, they're already doing back-end assembly for foundry as a foundry service for wafers that they haven't produced at all. So they're already doing very well on the packaging side. But to put the rest of the capacity in place and to get everything working, and even to staff up, because they're going to need dedicated engineering teams for pretty much every customer that they service. And that could be a few people to, as they indicated, a few hundred people for some of their major customers. So it's going to take time.
Cool. Hey, Karl, he's pretty good at this, isn't he?
Yeah, he's pretty good chip guy.
Pressure on him, and the guy just like friggin' wrapped things off. Like,
wind him up, let him roll.
Yeah. Well,
now he's going to tell me I'm talking too much again.
Jim's you're a pro. No. Hey, you were at these events, so I was at RSAC. I'm a little bit more diversified, so we're not going to talk about that. But I think we're really, really curious about what you saw at the semi-related conferences. No, RSAC, I already talked about it, so that's okay. We have a podcast on that. I got you guys covered. Don't worry. I don't have to rant about that. But hey, Karl, given that
CadenceLIVE,
almost most of the oxygen out of the room, But hey, let's talk about Cadence, because you're probably curious on what you missed out, right, Jim?
Yes, absolutely. I could not. They invited me, and I was already committed. So or I should be committed. One of the two. I can't keep it straight.
All right, let's put
CadenceLIVE was interesting. The two main things that came out were at the system level, where they brought up their new Millennium server. The first time Cadence has a full stack of EDA solutions, and not just EDA solutions. They have molecular biological solutions and other optimized design software, all running on NVIDIA GPUs. Actually, all running on Blackwell. So they introduced this new rack of looks like a NVL72, but it's a Cadence Millennium. And interesting enough, Jensen on stage ordered 10 systems. So these are $1.5 million a pop. So he placed a $15 million order on stage, surprised the heck out of Otterud, the CEO of Cadence, I think. Probably surprised a lot of guys at NVIDIA that, hey, you're going to have all this hardware. But, I think that was big news that they're really accelerating their entire stack now. Not entire stack, but what ostensibly is going to become their entire stack on NVIDIA GPUs. That's a very big deal. That's a very big deal. And puts them in a unique position. The other thing that really caught my attention was the agentic AI. So they had a slide that showed, the full stack of design and verification solutions, and the word agent was added to each one. And I asked the head of agentic systems at Cadence, so is there any engineering behind that, or is that just slideware? And he said, no. We've added software to each of these solutions that allow them to plug and play and combine them into whatever solution you need for your problem.
This is interesting. This is really interesting because this was one of the key topics at the Day Zero Hot Chips seminar last year. It was first off, it was very clear that even though you had AI capabilities throughout all these tools, most of the semiconductor firms didn't trust them yet. They would only use them for verification and validation. They wouldn't use them for chip layout. But the other question came up was, okay, do we put AI in the tools, or do we have an agent that more efficiently runs all the tools together? What was Cadence's view?
Well, I think they do both, right? So they have their Cerebrus, not to be confused with Cerebrus. So this is their solution for intelligent layout, saving people a lot of time, a lot of engineering time, also producing higher value chips, better performance, lower power consumption, all using AI to lay out the components of the block in a way that a human probably wouldn't even think of. And that perhaps don't even make sense intuitively, but really, through analysis. So think of it like playing a game of Go. You got 10 to 37 possibilities of ways to lay this chip out, and it will find, okay, if you want to optimize for power, you do it this way. You want to optimize for performance, do it this way. Right? If you want to optimize for chip area, you do it that way, and you can pick and choose what you want to do. Some people say, well, is this going to replace circuit designers? The answer is heck no. They got 5 more circuits they need to work on that are in the wings. So I think it does help somewhat address the skill gap that the industry is realizing today. And of course, Cadence and Synopsys providing the IP solutions that you can plug into whatever solution you're building. So between the AI portion of the story about agentic chip design, which is a real thing. They've got over 1,000 tape outs now using their AI layout tools. Cerebrus with a U, yeah. And so I think it's a big deal. It's going to help. I mean, take a look. You've got NVIDIA now have been saying for a year now, hey, we're going to go to an annual cadence, pun intended, annual cadence of chip releases. They didn't hire, an entire new 10,000 engineer workforce to do this. They're working smarter. They're using AI themselves to accelerate the chip design process, and therefore they can get more work done with roughly the same amount of engineers.
Well, so we're saying AI designing the chips, AI designing the systems, AI writing the code.
Not entirely. Well, see, that was the thing. I mean, I think, so Karl, I think you had a chat with Paul Cunningham, right?
Yeah, I did. Yeah.
And I ended up having like a mini roundtable with him, and I asked him those questions as well. Definitely a lot of progress happening in terms of identifying where generative AI, which has kind of taken now like LLMs, okay, because that was like the big thing last year, where agentic AI is able to accelerate and scale certain tasks within the design flow and process. They're still in kind of like this discovery mode, right? Definitely finding areas where both the more traditional stuff that they've been working on in terms of like the verification related AI applications and the generative design capabilities that they've had before, how that can be augmented with this agentic layer and, the application of let's say reasoning models. So on the model front, that part is still something that they're working on, right? So in terms of domain specific or building domain specific models, that's like a next step. But yeah, definitely are not at what a lot of folks in the industry are talking about, which is autonomous design, which, so we're seeing a lot of these representations of autonomous design that, borrow from the autonomous levels of, like the autonomous automation framework, the SAE levels of, vehicular automation.
Yeah, I was thinking Skynet, but okay, let's go there.
We're so Chuck Albert did get up on stage and say, "Hey, yeah, we're now starting to introduce level 4," which, okay, sure, but they did outline a roadmap. I think they're, based on my conversation with Paul, much more aware of like the challenges and issues and limitations of the technology, which I think is a good sign. How they get to 4, I still have a lot of questions about. And I'm hoping that, that's a discussion that we collectively will continue to have with Cadence. But, I want to go back to one of the things that really stood out for me. We've been talking about systems for a while on our podcast, right? This whole notion that Cadence is moving toward from a EDA company to an SDA company. And this is the thing that popped, right, Karl? Jensen got up on stage and they were talking about systems. And so in many ways, Cadence is being pulled toward becoming more of a systems, based design, automation, software company, right? And the really interesting thing about M2000 was now, as Paul would say, you're going from Boolean operations to now numerical and matrix math type stuff. That has huge implications because now, from a simulations perspective, you're starting to now take things to a broader level in terms of what you can simulate, and then take it into new frontiers that, oddly, these guys are talking about helping to design and model AI factories at like a infrastructure facilities level. So that's going from chip all the way to
data center,
like this massive scale, right? Which
And then you add in things like an NVIDIA Dynamo to orchestrate the AI at a data center level.
Yeah, so it's like some pretty crazy stuff in terms of expansion and what I would say is frontier expansion, and then there's the verticalization aspect because there was a lot of talk about drug design, which is in their parlance different from and actually in reality different from a drug discovery, right? So there's a lot of things to digest coming out of CadenceLIVE that I think have reflections on what's happening in the industry, but also are evolutions and transformations of what's happening with players like Cadence as these technological trends as well as industry trends are leading them in an entirely new direction, right? Mm-hmm. And we need to start thinking about them in a different way. And we heard that at GTC, right? That was like one of the things Jensen really wanted everyone to understand is like, look, we don't freaking make GPUs anymore, and we're not like a chip company, right? They've graduated from that. But anyways, how did I do? Okay?
Okay. Yeah.
Okay, well, we have to
go on 30 minutes.
I'm actually late for my next meeting. So, gentlemen, thank you so much. This is really fun, right? Not bad for being under time pressure, right? We got stuff out really quickly.
Absolutely.
Yeah. And so, hey, really quickly, share with our audience how they can get in touch with you if they don't already know that, which they should.
Yeah. Karl.Freund at Cambrian-AI.com. Go to Cambrian-AI website. You can see a lot of my work there.
Yes.
As well as on Forbes and EE Times and else.
Jim McGregor, TIRIASresearch.com. Definitely look for us on Forbes, EE Times, and other publications around the industry. I'll have more to say on that in the future. And look for our podcasts as well.
Yeah,
definitely like and subscribe.
Yes. And speaking of liking and subscribing, please subscribe to our podcast here, featured on the Next Curve YouTube channel. Also check out the audio version on Buzzsprout and find us on your favorite podcast platform. And also subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter. And we'll see you next time.
Look for Leonard and myself at Comdex.
Yes, we're gonna go hiking.
Yes, absolutely. And checking out some of the tech. Yeah.
Have a great trip, guys.
See you.